Homework from last day, 2C. Okay, so were you here last day? Okay. This says the sine of A equals what? Ah! A little alarm bell should go up. I said our cast rule, reference angle, two-quadrant approach doesn't work when I have something that equals plus or minus 1 or 0 or undefined. This here, I'm going to have to fall back on x and y and r. And so I start out by saying, which I should have done at the beginning of class and I forgot, but I'll do it right now. Sine is what over what in terms of x and y and r? And the fact that you're having to look it up, you in trouble. And if you are having to look it up, you need to write it or say it to yourself or do whatever you need to tonight. You need to come back Wednesday with that being a boring fact that you automatically know. Sine is what over what in terms of x and y and r? It's y over r. What this is really saying is that y over r equals -1. What we now need to imagine is how could this fraction work out to 1? The only way this could work out to 1 is if y was the same value as r, but negative. Okay? Here's my sketch. Because a fraction to be 1, it's something over itself, right? Here's my circle. Yes? And we called this distance here r, the radius, as we go around the circle. Right here, the x value is the same as r. Right here, the y value is the same as r, but positive. Right here, the x value is the same as r, but negative. But right here, the y value and the r value are the same, and the y value is negative. And so I say to you, my child, what angle is that? There is a slightly better way to do that, but I can't show it to you yet. This method that I just showed you is the most tedious, cumbersome method when dealing with plus or minus 1s or 0s. Eventually what we're going to do is we're actually going to quickly memorize what the sine graph, what the cosine graph looks like, and we'll do a quick sketch. For what it's worth, the sine graph looks like this, where that's +1, and that's -1, and that's 180 degrees, and that's 360 degrees, and right here is when you're -1 high, and lo and behold, that's at 270 degrees. That's the way we'll probably choose to do it, once we have the sine and cosine graphs memorized. Oh, and yes, the sine graph looks an awful lot like the letter S. That's convenient. Oh, don't want to erase that, Mr. Dueck. Don't want to erase that. Is that okay? Next. Did you get D okay? Because that's also a weird one. D is going to be a cotangent is x over y. If it's undefined, y is 0. Where is y 0? I think here and here. I think it's 0 and 180 and 360 if we go around again. Any others? Yeah. 6. Okay. Number 6. Theta is a second quadrant angle. What that tells me, Brett, is I'm here, and if I go C, A, S, T, tells me sine and cosecant are positive, everything else is negative. And they told me that the tangent was equal to this. What they've really done is they've told me that y is equal to √3 and that x is equal to 5. Oh, except one of them has to be negative. If I'm in this quadrant, what's negative, my x-coordinate or my y-coordinate? This quadrant, the quadrant 2 that they told me that this one, that I drew the angle in, this one. What's negative over there, x or y? Absolutely. Some of you look like you're confused, like you can't figure out what I'm getting. Look, you're to the left of the y-axis. I'm pretty sure you're a negative x. You're above the x-axis. I'm pretty sure you're a positive y. So I have that. I would also very much like to find that. It would be wonderful if there was some kind of an equation that would relate x and y and r together. Is there? Which one, Sandali? In fact, we can even go like this. Yes, it is. X squared, hey, that's 25, plus y squared. What's root 3 squared? Just plain old 3. R is going to be root 28. Now, they probably, in the back of the book, will write that as root 4, root 7. They'll probably write that as 2 root 7, because it is. Now I can find these. Cosine is what over what in terms of x and y and r? It's x over r. It's going to be negative 5 all over 2 root 7. Is that exactly what it looks like in the back of the book, or have they rationalized the denominator in the answer key? Can someone look? That's my way of saying, can someone check? Does it actually say negative 5 all over 2 root 7, or does it say negative 5 root 7 over 14? Negative 5 root 7 over 4. So they've rationalized the denominator. What I said to you guys, you don't need to do that. We're not going to be fussy on that. Now, if you're saying to yourself, how do I know if my answer is right? Negative 5 divided by bracket 2 root 7, close bracket, I get that. Or negative 5 times root 7 divided by 14. Geez, do I get the same answer? It's the same. No, that's how you can check quickly. If it was multiple choice, this is the answer I would have for you to pick from. Cosecant. Okay. Cosecant goes with which trig function, Brett? So it's r over y. It's going to be 2 root 7 over root 3. Now, I'm okay with that. I'm willing to bet in the back of the book they multiplied the top and the bottom by root 3 over root 3. They probably have 2 root 21 over 3. Is that correct? If you can just keep your finger there, because I'm going to be asking that same question on the next one, too. But, yep. And cotangent. That's y over x. No, Mr. Dueck. That's tangent. Cotangent. That's x over y, which is going to be negative 5 over root 3. And I'm betting in the back of the book they wrote that as negative 5 root 3 over 3. Is that right? Is that what you're wondering, why your answers were different from the back? Or were you able to get, these answers okay? Okay, so, sorry, Alberta. Any others? Well, then I got a take-home quiz for you. I take that back. I'm going to give the quiz out on Wednesday. So, next lesson. Radian measure, lesson 4, which is page 249. Today is the day, the momentous day. We are going to leave degrees behind. We are moving on. We've broken up with degrees, and we are in a permanent long-term relationship, a stable relationship with radians. Now, degrees is going to write us letters. Degrees is going to send us emails. We'll get late-night phone calls begging us to come back. Resist the temptation. And what I really mean by that, Ryan, is every year I have 1 or 2 kids who are so uncomfortable with radians, they change it all to degrees. They solve the question in degrees, and then they change their answer back to radians. Don't do that. You will never master it if you do that. It's going to be confusing for a couple of days. Please trust me, if you are willing to butch through, if you are willing to force yourself, if you are willing to push yourself, suddenly it'll be there. But if you constantly make the conversions, it'll never be there. Starting out, warm-up number 1. What's the formula for the circumference of a circle of radius r? Well, symbol for circumference is that. What is the circumference of a circle? What's the equation? Pi r squared is area. What's the circumference? Anybody know it off the top of their head? 2 pi r. In fact, if they wanted me to find the circumference of this circle, I could say c equals 2 times pi times 5. And I told you that your test was going to be non-calc. What we're going to do is, if there's a pi in the equation, we're just going to leave our answer as an exact value in terms of pi, because pi is a repeating decimal that goes on forever. Yes, I know 10 times pi would be 31.4159265358997. Forget it. We're just going to leave our answers in terms of pi. In all of our previous angular measure, we've used degrees. There's 360 Eric degrees in one circle, or 1 degree is 1/360th of a revolution. In order to simplify some of the calculations used in trig and calc, mathematicians use an alternative angular measure, radians. Radians is better in every single way except one. Joel, it's really tough to do it in your head. That's where degrees is nicer. If I say to you, what's 50 degrees, take away 30 degrees, Spencer, what's the answer? 20 degrees. What's pi by 3 radians, take away pi by 7 radians? Okay. But in every other way, it's superior. So, bear with me. Radians are defined. They're a ratio, and it's defined as the length of the arc subtending the angle divided by the length of the radius. Say what? Sounds confusing, I know. Here's how a radian is defined. If you take a circle. Doesn't look like a circle, Mr. Dueck. Yeah, I know. Is that a circle? Pretty close. And you take the radius, and then you draw an arc exactly the same length as the radius. I'm eyeballing it. Right about there. This here is 1 radian. Symbol for radian is RAD, or nothing actually. Technically it's not a unit, but we write rad. Well, that's kind of a, well, what it does then, it allows us to define an angle in terms of the size of the circle that it's in, which is, although you don't know it yet, Kara, going to be very, very useful. 1 radian, all of you guys go like that. 1 radian is about there. If you imagine your arm being the radius, and if you move the arc about the length of your arm, about that. It's 1 rad, give or take. Okay? And the nice thing is, whether you're Trevor, who's 6'6" with long arms, or, well, with shorter arms, it doesn't matter. You'll go through the same arc length, because with Mitsu, okay, right? With Trevor, where's my meter stick? You know, it would still work. So it says, use the diagram and definition to estimate a radian measure. It's about that. How many degrees? It says use diagram 2 to estimate the degrees. Not gonna. We're leaving degrees behind. Emily, that relationship is off. Don't return the calls. Hang up when you see it on your cell phone. Next page. We are going to have to learn to convert from degrees to radians. Angles can be measured in either, and I am going to ask you to flip-flop going from one to the other, usually from degrees to radians. Once in a while, we will go back. I've fibbed a little bit. I've exaggerated a little bit. Once in a while, we'll go back from radians to degrees. So we need a conversion factor. Consider a circle with a radius of r units. It says complete the following. What's 1 complete rotation of a circle in degrees? 360. What's the arc length for one complete rotation? Well, the arc length for one complete rotation is the circumference of the circle. And what was the equation for the circumference of the circle that we looked at about 30 seconds ago? What's the arc length going to be? 2 pi r. Now stay on this page. We said that the measure of an angle in radians is the length of the arc divided by the length of the radius. If you want to figure out how many radians in one circle, it's the length of the arc divided by the radius. What do you notice happens here? Something cancels. What cancels? 360 degrees is 2 pi. There are 2 pi radians in a circle. (360 degrees is 2 pi. What do you think 180 degrees is then? Pi. You need to memorize that. Now, you will, because we're going to be using it over and over and over and over and over and over and over. But much like y over r, x over r, and y over x for sine and cosine and tangent, if you see a quiz or a test approaching and you don't have that at your fingertips, you have little chance of passing. Tells me you haven't done the homework. So 1/2 a rotation in degrees is 180 degrees. The arc length for the 1/2 rotation, well, you know what? Let's just jump to the punchline. Here is my conversion factor. Pi equals 180 degrees. Pi radians is 180 degrees. Now we have to be a bit fussy. In mathematics, that's the degrees symbol. If there is no unit after the number, because technically it's, if you look at the units up here, it's meters divided by meters or centimeters divided by centimeters. Radians actually, Vlad, technically have no unit. So if you see no unit, it's radians. But because people don't like no unit, sometimes they'll write rad next to it. No, that means actually radian is short for radians. In other words, that's sine of 90 degrees. That's sine of 90 radians. You know how I can tell? Because there's no degrees symbol. And I'm going to be fussy on that from now on. If you don't put a degree symbol, I will assume you mean radians. Example 1 says, complete the chart. 360 degrees, we already said, was 2 pi radians. The one that I have memorized is this. 180 degrees is pi radians. How does that help me? Well, 90 degrees is what fraction of 180 degrees? 90 degrees is pi by 2. You can say pi divided by 2, pi over 2. For some reason, mathematicians have picked a bit of a shorthand when it comes to radians, and they just say pi by 2, and we clue in that you really meant pi divided by the number 2. Oh, 60 degrees is what fraction of 180 degrees? Pi by 3. (45 degrees is what fraction of 180 degrees? It's 1/4. 45 degrees is pi by 4. (30 degrees is what fraction of 180 degrees? 30 degrees is pi by 6. You see why that pi 180 is a handy one to memorize? You can get an awful lot of them. In fact, you know what? We can even do a bit more than that. You guys keep that little chart in front of you. 120 degrees. Isn't that 2 60s? Yes? What was 60 in radians? Oh, 120 degrees, that's 2 pi by 3s. It is. In fact, I can find any multiple of 30 or 45 or 90 or 60. It's not that hard. Not that hard. 210 degrees. Hey, that's 7 30s. What was 30? Dominique? You know what? 270 is 7 pi by 6. Okay, what about 113.2 degrees, Mr. Okay, we're gonna come up with a mathematical algorithm that will let us handle anyone, but for a lot of the most common nice round numbered degree angles, right, not that hard to jump back and forth. Okay. Says the rule to convert from degrees to radians is to multiply the angle in degrees by Let's look at this 113.2 degrees. What did I tell you to memorize? What was the conversion factor? What two angles do we know are the same? 180 is the same as? Okay. I know this. I know that 180 degrees is the same as pi. This is my conversion factor. If I want to go from degrees, and it's a yucky number, to radians, I'm going to multiply by pi over 180 degrees. Why do I know that I want the 180 degrees on the bottom? Because if you've done physics or chemistry, what we're really saying is the degrees cancel. We're using a little bit of unit analysis. And then I would get out my calculator for a yucky one like this. I would go 113.2 times pi divided by 180. The rule is to multiply by pi over 180. I truthfully don't memorize the rule. I know it's either going to be pi over 180 or 180 over pi, and I want to make the units cancel so that I end up with the units that I want on top. If I wanted to convert 270 degrees, now there's two ways to do this one. The first way is to say, hey, that's 9 30s or 3 90s. In other words, if it's 3 90s, it is 3 pi by 2. That's the intuitive way. But if I want the algorithmic mathematical way, I would go like this. I want to get rid of degrees, so I want my degrees to be on the bottom. The pi is going to be on the top. And when I do that, I'll get 270 pi over 180. And I'll also write that a little bit neater. 270 pi over 180. No calculator, put it away. I'm going to suggest that the tens cancel. It did say give your answer as an exact value in terms of pi. 27 over 18. Dominique, what goes into the top and the bottom evenly? Oh, so are you telling me that this is, it is 3 pi by 2, which I said because I noticed it was 390s. Either way gets you there, Ryan. 315 degrees. It's a certain number of 45s. I think it's 7 45s. But because I'm not, I think it's 7 pi by 4. But because I'm not sure, I'll use my conversion factor. I'm going to multiply this by pi over 180. And I get 315 pi all over 180. The degrees cancel. Now, to reduce 315 over 180, and if this was not on the calculator section of the test, and it will be, well, what number goes into the top and the bottom? Definitely. Five, yes, yes. But most of you don't know that 45 goes into the top and the bottom. It does. Let's suppose you only saw the 5. What's 180 divided by 5? Oh, no. Well, let's see if we can figure it out. What's 180 divided by 10? 18. What's 180 divided by 5? Twice as much, 36, because 10 is half as much as... It's 36. What's 315 divided by 5? Well, I don't know. Well, 300 divided by 5 is 60. 15 divided by 5 is 3. I would get that so far if I was hopscotching my way there. Oh, and what goes into 63 and 36 evenly? 9, 7, 4. And hey, I was right. I said I was pretty sure it was going to be 7 pi by 4. Can be done with or without a calculator. Example 3 says convert the following from degrees to radians. What does it say in brackets, Ryan? That tells me I'm supposed to use a calculator. My little tricks won't work. So 70 degrees, I'm going to multiply by pi over 180 degrees so that my degrees cancel. And I'm going to get 70 times pi divided by 180, which is what on your calculator? Where's the pi button, Mr. Dueck? Right there. 70 times pi divided by 180. 70 degrees is about 1.22 radians. Oh, to the nearest tenth. 1.2 units. You can write rad. It's not real wrong, but there's no units. No units is radians. 205 degrees. Going to multiply by pi over 180 degrees because I want the degrees to cancel. It's going to be 205 pi over 180. Do I need to press times? Oh, I don't need to. I pressed times in the previous one. I guess I don't need to. A little shortcut. 3.6. Radians. That's going from degrees to radians. Occasionally, you'll also, Eric, need to go from radians to degrees. So 2 pi radians is how many degrees did we say? 360, which means pi radians is what? 180. Half pi, pi by 2. Well, what's half of 180? 90. A third of pi, pi by 3. Well, what's 1/3 of 180? 60. Pi by 4, a quarter of 180, 45. Pi by 6, 30. Or pi by 180, what's 1/80th of 180? 1 degree is the same as pi over 180. The rule is, I guess this time, we're going to multiply by 180 degrees over pi, and that will introduce degrees to the equation. Again, but I don't memorize the rule. I know the conversion factor, pi 180 degrees, pi 180 degrees, and I just ask, which one needs to be on the top, which one needs to be on the bottom to cancel out my original units? Pi by 4? Oh, that's 45 degrees because it's sitting right there. Negative 7 pi by 3? Well, the answer is going to be negative. Brianna, what was 1 pi by 3? What was a single pi by 3? How many degrees? 60? What do you think 7 of them is? Whatever 7 times 60 is. 420. And Carly? Wrong? Right. Half mark off? Correct. I'm going to be fussy now. Now, those ones were ones we could kind of do in our head. I'm also going to give you yucky decimals. How do I know I'm supposed to use my calculator for number 6? Tyler, what does it say in brackets? Okay, so now I'm actually going to use the conversion factor. It's going to be 1.57 times. I want the pi on the bottom. I want the 180 degrees on the top so that the units that end up on the top are degrees. What is 1.57 times 180 divided by pi? Should be really close to 90. Because 3.14 divided by 2 is 1.57. It should be really close. Is it close to 90? What do you get? 89.95, and it says to the nearest tenth, so if you round it off properly, it's going to be 89.99. No, it is going to be 90, yeah? 3.2, if I want to change that. How do I know this one is in radians? It doesn't say radians. No degrees symbol. .2. Hang on, Mr. Dueck. I wrote that one wrong. went from radians to degrees. Let's try that again, Mr. Dueck. Times 180 degrees over pi. I want the degrees to be on top. 3.2 times 180 divided by pi. 3.2 radians, 183.3 degrees. Try C on your own. Negative 1.4 radians. How many degrees is that? You get negative 80.2? Yeah? Degrees. So here is the conversion chart. If you're someone who just has to memorize stuff, you can memorize that. I just know the conversion factor. Pi is 180. Pi is 180 degrees. Pi is 180 degrees. And then, Carly, I use what I've learned from physics about canceling units and tricks like that. I want the units that I want to cancel to be on the bottom. I want the units that I want to end up with to be on the top. Oh, you can also use 2 pi equals 360. Can we all agree that pi and 180 are nicer numbers to deal with? Because there's no 2. Okay. Example 7. Use your calculator in degree mode to find the value. First thing we need to do is we need to make sure our calculator is in degrees. Press the mode button, which is right there. Make sure you're in degrees. And they want us to find the value to 4 decimal places. So sine of 45, 0.7071. 0.7071. How do I find secant? The answer is I don't. Don't have a secant button. What does secant go with? Okay, secant of 135 is actually going to be 1 divided by the cosine of 135. The most common mistake here, Eric, is kids, instead of going 1 divided by the cosine, they go cosine of 1 divided by 135. They want to flip the degrees and not the... It's the reciprocal of the cosine, not the reciprocal of the angle. The secant of 135 is degrees is negative 1.4142. Negative, does that make sense? Oh yeah, cast rule, it should be negative. I could have anticipated that. B says use a calculator in radian mode. Okay. Now is the time, finally, at long last, mode radians. But I like degrees, Mr. Dueck. Trust me, degrees was a high maintenance relationship. It was going to end up being one of those where you just went, oh, if I'd known what I was getting into, I never would have committed to this, ever. Radians, although it's going to take a little bit to break the ice and get the conversation going, oh, I'm telling you, you'll just be like, such a great part of my life now. Sine of pi by 4. Sine of pi by 4. By the way, it's the same answer because 45 degrees is pi by 4 radians, so I should get 0.7071. Secant of 3 pi by 4, that's going to be 1 divided by the cosine of 3 pi by 4. And 3 pi by 4 is 135 degrees. This should give us the same answer, which it does. Negative 1.4142. So, to me now, it's fair game to ask you either degrees or radians. Can you try all of example C on your own, all 4 questions? Here's a hint. Do all of the radians first, and then do all of the, or do all of the degrees first, and then do all of the radians, but don't flip for each question. Little trick. I'll freeze the screen, and I'll do the answers, and then bring them up. See if you get what I got. Nope, let's try that again. See if you get what I got. By the way, Brett, the very last one, 45 radians or degrees. Okay? Radians. Why? Now, there is no provincial this year, but they loved this question. They loved to give the kids a familiar angle, like 30 or 45, or the really tempting one was 90, and they would not put a degree symbol next to it, but they would have the degrees answer to pick from on the multiple choice. In fact, if they were in a really mean mood, Alan, they would make that answer A, so it was the first one you spotted, and they would get a lot of kids. I just gave you a hint. If they knew on a provincial, Mr. Dueck, you knew on your hat, maybe. Okay. Now we need to get used to the cast rule and reference angles with radians. Turn the page, please. It says, in each of the following, 1. Draw the angle theta in standard position. 2. State the principal angle. 3. Find one positive and one negative coterminal angle. We're going to add a fourth thing. Really? Try that again. I froze it twice somehow. And we're going to add a fourth thing. Thank you, Spencer. The fourth thing is this. Find the reference angle. And here I'm going to do you a favor. When I first started teaching this, oh good gosh, 12 years ago now, I was terrible. Because I do fractions intuitively. I'm good at fractions. Most of you are not. So I'm going to give you a very easy 1-second workaround that will help you navigate your way through this. And we're going to start out by looking at example A, 3 pi by 4. I have no idea where that is. Here's what we're always going to start out by doing. We're going to say, that's pi. Because how many degrees is that right there? 108, how many radians? Pi. Is that okay, Emily? What number is in front of the pi? It's invisible. A 1. What's my denominator that they gave me in this particular fraction degrees? In this particular fraction radians. Instead of writing pi, I'm going to write this, 4 pi by 4s. Is that still 1 pi? Write that. And then put your pencil down for a second and turn your brain up. Trevor, how far to here? You just swore in my class. We've left degrees behind. She's not worth Come on, Trevor. Leave her behind. And that's not what I wrote. Ready? How far? Read that. Can you say 4 pi by 4s? 4 pi by 4s. Okay, nice and loud again. How far? How far? Think about it. If all the way is 4 pi by 4s, how far? Let's write that down. By the way, although it's unnecessary, how far? 8 pi by 4s? Yes? 6 pi by 4s. Here's why we went to the fractions. What angle did they give me? If that's 2 pi by 4 and that's 4 pi by 4, can you tell me exactly where 3 pi by 4 is? I think 3 pi by 4 is exactly halfway. Is it not? Yes? Yes? No? Eric, yes? No? Yes? No? Yes? Have I lost you? If I have, I can Yes, I've lost you, or yes, you got it? You sure? Because I had no reaction from you whatsoever. Okay? So the angle is that right there. We've drawn it in standard position. Part 2 said, state the principal angle. Now, the principal angle in degrees was always between 0 and 360. What will the principal angle in radians be between? It'll be between 0 and 2 pi. Is this between 0 and 2 pi? Then it is the principal angle. Three says, find one positive and one negative coterminal angle for the angle theta. Well, if we were in degrees and we wanted to find coterminal angles, do you remember what we added? Or subtracted? 360. What about for radians? I'm going to add or subtract. Okay, so I'm going to say 3 pi by 4 plus 2 pi. And I'm going to say 3 pi by 4 minus 2 pi. No, I'm not. That's dumb. I'll write that just this once. But that's... why confuse myself? Back to our diagram. Are you ready? Are you ready? Are you ready? Trevor, are you ready? Scene 1, Act 1, Take 2. How far? How far? 8 pi by 4. Yes? 2 pi is 8 over 4. Huh? What did I just say? 2 pi is what? I'm going to go common denominators right away from the very start. My common denominator is always going to be the bottom of my radian fraction. Because what is 3 pi by 4 plus 8 pi by 4? How many pi by 4s? 11 pi by 4s. See how it kind of pops out? And what's 3 pi by 4s? Take away 8 pi by 4s. Negative 5 pi by 4s. And the last thing I asked for was the reference angle. The reference angle is that one right there. So we said reference angles were defined as. Joel, what's this measure right there? What's this measure right there? What was our angle? Can you tell me how big this has to be? Doesn't it have to be a single... What? Yes. If you don't label them with common denominators, this gets way tougher. Way tougher. Don't write this down. Just watch. We're going to do one together. What if I gave you 11 pi by 6? I would go like this. No. What's my denominator? This is 6 pi by 6. What's this then? 12 pi by 6. By the way, what's this then? 3 pi by 6. What's this then? 9 pi by 6. Where is 11 pi by 6? Can you see, Joel, it's just shy of 12 pi by 6? In fact, I can tell you exactly how shy. I can tell you the reference angle already. How much below 12 pi by 6 is 11 pi by 6? What's my reference angle? 1 pi by 6. Pi by 6. Oh, and if you want me to find coterminal angles, I'll add and subtract multiples of 12 pi by 6. 11 plus 12, 23 pi by 6 is a coterminal angle. 11 minus 12. Negative 1 pi by 6 is a coterminal angle. Some of the denominators aren't quite so nice, like thirds, but that's okay. B. Pi. Well, actually, it says negative, so this is going to be negative, except what's my denominator here, Eric? I'm going to call it negative 3 pi by 3, and that makes this negative 6 pi by 3. Okay, we're going this way. What's this? Well, it's half of 3 pi by 3. What's half of 3? You know what? This is, and I'm going to write this even though it's sloppy. This is negative 1.5 pi by 3s, is it not? Right? It's half of 3 of them. Is that okay, Kara? Kara, what angle did they give me? What angle did they give me? Did you speak? You might have. Oh, we're going to go through this one again, are we? You're awake now? Say, what angle did they give me? Negative pi by 3. In fact, negative 1 pi by 3, I'm going to think to myself, because if this is negative 1.5 pi by 3, I think negative 1 pi by 3 is a little shy of negative 1.5 pi by 3. Is it not? Trevor, the other way to think about it is this. From here to here is 3/3. There's 1/3. There's 2/3. There's 3. I kind of divide it into 3 chunks in my head. Except I'm going to get rid of that second line. Whoop, not the first line, just the second line. Emily, is that okay? Or have I lost you? You're not convincing me. Your face is saying I have no idea what's going on. Your tone is saying I'm confused. Your voice is saying I got this. Right now, 2 out of 3 things are telling me I need to re-explain. Ask. What's your question? Okay. How far? Negative what? How far? Negative what? Negative 3 pi by 3s? What's half of 3 pi by 3s? Negative 1.5 pi by 3s. Right. What's half of, in other words, our measure is going to be pi by 3s. 3 of them to get to there. What's half of 3? What's half of 3? What? So half of 3 pi by 3s would be 1.5 pi by 3s. Negative, because we're going in the negative direction. That's just telling us to go that way, right? Is that okay? Yeah? Because I can tell you now the principal angle. Now, the principal angle is this way. It's that way. Let's come back to the principal angle in a second. I want to do the reference angle. The reference angle is this big. How big is this? Heard it. The reference angle is pi by 3. How's that help? Huge. Why did you do reference angle first and then do watch. Ready, Carly? Look up. We're going to go in the positive direction now. How far all the way around the circle once? And don't tell me 2 pi. We're using a common denominator. How far all the way around the circle once? No. We're going this way. We're going this way. We're going this way. We're going this way. We're going in the positive direction now. How far all the way around the circle once? Positive 6 pi by 3. What was the reference angle? So, how far to here? You're missing it. Ready? Ready? Guys, look up. How far all the way around? 6. How big is this? 1. How far? 5 pi by 3s. Yes? That's our principal angle. I can't have it work. The angle between 0 and 2 pi, the smallest positive angle. In degrees, it was the angle between 0 and 360. Because for all of these, there's an infinite number of angles that we could use. We keep going coterminal, 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 coterminal. Yes? Principal angle we defined as, way back when, in lesson 1 before Christmas, we defined the principal angle as the angle between 0 and 360. The smallest positive angle. Is that okay? You sure? Okay. Almost done. Example 9 says, find the reference angle for the following rotation angles. Anytime I'm doing radians, if they give me an angle, I do a sketch. 5 pi by 6. That's pi. That's 2 pi. Except What's the denominator that they gave me here, Isabel? I'm going to call this 6 pi by 6s because that's still 1 pi. What am I going to call 2 pi? 12 pi by 6s. How big is right here? 3 pi by 6s because it's halfway to 6 pi by 6. How big is right here? 9 pi by 6s. Yes, yes. What angle did they give me? Joanne? Okay, 5 pi by 6. I think, isn't it right there, just shy of 6 pi by 6? Can you tell me the reference angle? What's left over? Ah. B. Negative 5 pi by 4. Negative means we're going in this direction. So this is negative pi. Well, no, it's negative 4 pi by 4s, which is still negative pi. This will be negative 8 pi by 4, which is negative 2 pi. How big would this be right here? Really? How far? How far? Hello? How far? Hello? Negative 4 pi by 4. How big is halfway then? How big is this up here? Spot the pattern. What angle did they give me? Negative 2 pi by 4, negative 4 pi by 4, negative 5 pi by 4, I think is right there. Because 6 pi by 4, negative 6 pi by 4 is too far. There's my reference angle. How big? Kara, you're right. Loud. Yes. C. What's my denominator here? I'm going to call this, instead of pi, 3 pi by 3 and 6 pi by 3. So you ready? Here we go, here we go, here we go. How far? Sorry? 3 pi by 3. How far? 6 pi by 3. How far? 9 pi by 3s. How far if I went to there? 12 pi by 3. Too far. How much too far? In fact, I think I want to go there. Oh. What's the reference angle? You already said it. When I asked you how much too far, what I was really saying is, what's the reference angle? Pi by 3. We need to practice this a lot. Okay? Moving around the circle in radians needs to become fairly casual. I won't say second nature, but almost. Homework. One, two, 3, 4. I'll skip 5. 6, 7, 8, 9, 10, 11. So I think I skipped 5. Need to practice this. Good news is I believe next lesson is a bit shorter with less homework. Let me double check. Applications. Yeah, shorter lesson, next lesson. Take-home quiz next class. Physics 12 tutorial today after school.